Okay, team, we are going to go over sample space with probability. So sample space, let me zoom in here for you. Maybe, here we go. Sample space. Basically, sample space is a list of all the possible outcomes of some event. Okay, so we've been talking about probability. We know, like, for example, flipping a coin. The possible outcomes there would be heads or tails. So that list of heads or tails, that is actually called sample space. So when we're talking about sample space and probability, you can display it in a few different ways, and we'll go over these more tomorrow. But basically, you can display it with lists, so just basically write out the different outcomes. You can use tables, tree diagrams, which we haven't talked about yet, but we will in the next couple days. Sample space can be used to determine the probability of simple or compound events. We've only been talking about simple events so far, but we'll get into compound events in the next couple days. So let's go over a couple examples of sample space. Okay, so here's our first example. Talking about soccer here, or football. So let's say that Real Salt Lake and the New York Red Bulls are playing a game. What are the possible outcomes of this game? So in this case, we're asking what is the sample space for this game? Essentially, there's three different outcomes, right? The first one, we could say that RSL wins. In this case, New York loses. Okay, really we only need to put this part, but I'm just making it clear what's going on. The second outcome would be New York wins, right? Which means that RSL, Real Salt Lake, loses. Okay. The last outcome would be a tie between RSL and New York. Okay, so the sample space then, if we wanted to write the list of sample space, promise I can spell, you guys. The sample space then, if we're writing it as a list, could be RSL wins, New York wins, or tie. Okay, so there's one example of sample space. Let's go over a couple more though. Let's do that one next. Okay, so another example. Let's say we're playing Hangman with math vocabulary, of course, because this is a math class. What is the sample space for the word the students or the class would guess? So we know when we're playing Hangman, you could use any word. So say this is the phrase that we're trying to get people to guess. Notice how there's multiple A's, there's multiple N's, right? Are there any other multiples? No. Okay. So a lot of people think then the possible outcomes for Hangman, the Hangman game, would be each of these letters. However, think about the game Hangman though, right? The possible outcomes for the word or phrase that we're guessing is actually the entire alphabet. So 26 letters, right? Or if we're asked to list the sample space, we would actually have to write out the alphabet, right? A, B, C, D, E, F, G, H, I, J, K, L, M, and O, P is taking longer than I thought. Q, R, S, T, U, V, W, X, Y, and Z. You guys know the alphabet. Okay. So again, it's the entire alphabet that is our sample space in this particular case. because we're not just saying, what is the sample space for spelling the phrase hangman, right? We're saying, what is the sample space for guessing the phrase, right? Let's go over another example that's similar to this one, but it makes a very important point. Okay, let's consider the phrase, okay, boomer. What is the sample space for spelling this phrase? So now in this case, we're not asking people to guess the phrase, so we're not using all the letters of the alphabet here. We're actually just looking at these specific letters. Okay, boomer. Okay, but the really important thing here is what letters are needed to spell it. Okay, notice how we have multiple O's, right? So in this case, we don't actually need to list the multiple O's. So don't list multiples when we're talking about sample space. Okay, so instead of writing this whole thing right here for the sample space, our sample space is actually going to be, let's use purple. Okay, our sample space is going to be O, got the O, K, A, Y, B, and we already used O, so we don't need to write it again, M, E, R. Okay, so again, the important thing with sample space is that you do not list multiples if there are any. Okay, hopefully that example makes sense. Let's go to another one. Sample space. Okay, let's say we have a number cube, which is just a normal six-sided dice. Sometimes they call it number cubes. Let's say we're rolling this dice. What is the sample space for this event? In other words, what are the possible outcomes when we are rolling a dice? So because this is a normal six-sided dice, we know that the sides of the dice have these specific numbers on them. 1, 2, 3, 4, 5, and 6. So this list right here, this is our sample space. Okay. Now, just to kind of reiterate the last example, let's say that we have a weird number cube that has, let's see, weird dice that has 6 sides still, but in this case the sides are numbered 1, 1, 2, 2, 3, and 3. Okay, so in this case, our sample space, because we don't repeat things, wow, can't spell today, repeat things, just getting ahead of myself because I'm so excited about sample space. We don't repeat things, so in this case, our sample space would be sample space would be 1, 2, and 3. Okay, so it's the possible outcomes, and we don't need to list multiples. Okay, I hope those examples help. Again, really, we're just listing the possible outcomes of events, kind of like we have been doing the last couple days to find probability of things, right? We need to know what the different outcomes are if we're spinning a spinner, right? Or rolling a dice. Okay, hopefully that helps. If you have any more questions about sample space, though, let me know.